Hi everyone, welcome back. Let's see the problems of synchronization mechanism with busy waiting solutions. Guys, before moving for the problems of synchronization mechanism with busy waiting solutions, let's see what are the various kind of algorithms that we have seen so far under busy waiting solutions. First one will be a lock variable. The problem with this lock variable is it is not satisfying the primary goal of synchronization algorithms, that is mutual exclusion, right? As it is not satisfying this particular condition, we are moving for the other approach, that is test set lock variable approach, right? In test set lock variable approach, it is satisfying mutual exclusion property and progress property. These two are satisfied, but it is failed at bounded waiting and architectural neutrality, right? So we are aiming at to have a solution which can satisfy all the conditions. So for that reason, we are moving for another solution. That solution will be strict alternative approach, or I can call it as turn variable approach. Hope you understood why I am calling this as turn variable approach, that I have covered in the earlier videos, right? This particular approach will satisfy mutual exclusion property, bounded waiting property and architectural property, but not satisfied with the progress. Again, the problem here is progress is one of the primary goal of the synchronized algorithms. That's why we'll move with another kind of algorithm, that is interested variable approach. The interested variable approach can satisfy mutual exclusion property and the progress property, means both the primary goals are satisfied, and coming to the secondary goals, it is satisfying architectural neutrality, but it is failing at bounded waiting, right? It's not exactly bounded waiting, like it is not, it is a kind of problem, okay? But the thing is, here the problem is more than the bounded waiting problem has occurring, that is deadlock is occurring. So deadlock is more problematic than the bounded waiting. That is the reason we are moving for one more kind of algorithm, that is Peterson's method. So this is the algorithm which can satisfy all the four conditions. One will be mutual exclusion is satisfied, progress is going to be satisfied, bounded waiting is satisfied, and architectural neutrality is going to be satisfied, right? Yes. So finally we got the solution which an algorithm can provide all the four conditions. Okay, these are the 5 algorithms that we have seen under busy waiting solutions. Okay, fine. So if you look into the exact concept, what we are trying to look about this busy waiting solutions is problems, right? So guys, if you look into in these kind of busy waiting solution algorithms, something like we are getting some kind of code where you can observe while something like count double equal to n followed by semicolon. What is the meaning of this one? When a particular condition is satisfied, then it is always going to be in the busy waiting state, right? As soon as it is getting the chance, it is going to always in the busy waiting mode, right? Something like if I say any kind of a room where somebody is there inside the room, if I visit here and if I thought somebody is inside the room, I will wait here outside and I will always knock the door. Always knock the door. This is what we can say that busy waiting state, right? The first problem is here busy waiting state, right? What will happen if it is going to be knock the door always? The problem is CPU will allocate some time to each and every process. Am I right? Let's say 5 nanoseconds, right? As it got the 5 nanoseconds of CPU and it is wasting some 4 nanoseconds or 4.5 nanoseconds at the knocking itself. Then it means, is it wasting the time or not? Yes. Simply I can say that it is wasting the CPU execution time, right? When it is under the busy waiting mode, as soon as it get the chance, it is trying to enter the critical section by knocking the door, right? So which means indirectly I am saying that you are wasting here CPU execution time, right? That is one of the problem we are going to face in the with busy waiting solutions. And another kind of problem will be priority inversion. The meaning of this one is, if I say this is a kind of a critical section, assume that there are two processes P0 and P1 which are having the priority as 3 and this having the priority as 4, and these are available in the ready queue. When they are available in the ready queue, CPU scheduling algorithm will work and given chance to which process? Assume that the process which is having the highest priority will get the chance. Now then, process P0 get the chance and entered into the critical section. But is it directly entering into the critical section? No. First it will execute the non-critical section, then it will satisfy the entry section criteria, then it will enter into the critical section. And while it is coming out, it will perform the exit condition, then it will comes out and then will give a chance to next readily available process which is in the ready queue. Am I right? Yes. So now when process P0 enter into the critical section by satisfying the entry section criteria, it means that P0 is using the resource entry section. Am I right or not? Yes. Now suppose for example, while P0 is executing, there is another process P2 come into the picture and having the priority as 6. Now process P0 having the priority as 4. Now what the CPU scheduling algorithm will do? CPU scheduling algorithm will preempt this process from the critical section, and given chance to execute the P2. Now P2 executing at what location? In the non-critical section. Assume P2 also wants to use the critical section. Then what it will do? It will go for the entry section criteria. If you look into the entry section criteria, it is not going to be satisfied. What will be the reason it is not going to be satisfied? Because according to the P0 is already in the critical section. So I won't allow you here. Right? So that's the reason I can say that P2 is going to be blocked at the entry section. Am I right? Yes. The reason is that entry section is handled by P0. Now CPU is handled by whom? That will be handled by P2. If you are able to clearly observe here, P2 is handling the CPU and P2 is handling the entry section. Now just think about this, it's a kind of a lock or not. If P2 wants to enter into the critical section, it has to satisfy entry section. It has to satisfy entry section. But if P0 wants to leave this entry section, it needs CPU. If you look into this particular structure here, it look like kind of a loop or not. Yes. I am depending on you and you are depending on me. At the same time, you are going to get a problem called deadlock. Right? So means P2 is never going to leave this hurdle and P0 is never going to leave this exit hurdle. Right? So when the P2 get the chance to execute, whenever P0 will execute the exit condition. Right? But if P0 wants to execute the exit condition, it requires what? CPU. P0 requires CPU. That's why it's going to be always in the deadlock, and this is what generally we'll call it as a kind of spin lock. Right? So which I can say it is a kind of a deadlock. Right? So this is one of the problem of synchronization mechanism with the busy waiting solutions. Then what will be the solution for this priority inversion? The simple thing is, blindly you can increase the process which are in the critical section with the same priority number. Right? If a process is in the critical section and if there is any higher precedence process will come into the picture, here I will make this as 6 so that it will execute first, then it will execute the P2 process. Means I can apply the solution as priority inheritance. Priority inheritance means the process which is getting executed even I am in the critical section, the priority I am going to be allocated to the process which is in the critical section. That's where this deadlock problem is going to be eradicated, because if it's having the same priority 6 and it's having the same priority 6, what you are going to consider? You are going to consider arrival times, and then arrival times of P0 is before then P2, so P0 is going to be executed first, then P2 is going to be executed. This is where our problem is going to be solved. And then how we are going to avoid CPU wastage time? Right? That is what we can do with the help of sleep and wake up system calls. Okay, fine. So in the next video we'll see what is sleep method and what is wake up method, all these things. Hope you understood these problems clearly.